Okay, let's start our today's lecture. Welcome to the class. First of all, there are some rules for online class, and that is be punctual and ready to learn. Mute your microphone when you are not speaking. Raise your virtual hands to speak. Keep your cameras on and stay focused. As I have already mute you all, if you have any question related to the concept, you can just raise your hand. Okay, at the end of the lecture, I will be questioning some of the concepts related to the lecture. Okay, so let's start our today's lecture. As our today's lecture is actually belongs to the linear functions. What does this linear function mean? Why we are studying the linear function? What is the real life application of linear function in our daily life? Meanwhile, as we have already done the coordinates, the x coordinate, the y coordinate of the Cartesian plane, it all relates to the function. What type of function is that? Why we are studying linear functions? If I'm saying the rate of change is constant, then we are actually talking about linear functions. Clear? If I'm talking about the rate of change, which is constant, I'm talking about the linear function. Linear function means that the highest value of the variable x is, the highest power of the variable x will be 1. If the variable x have more than 1 power, then the function is not linear, it will be quadratic. Okay, let's start with the linear functions. If I'm talking about the linear functions, I just said the rate of change. If the rate of change is constant, anyone who can tell me any real life example of the rate of change if the rate of change is constant? Anyone? Raise your hands if you know any example from the real life that the rate of change is constant. If we are doing something and the rate of change is constant, we are actually talking about the linear function. Then please, can you tell me what are the real life examples of linear function? Anything which can be moved, which is moving in a regular pattern, or which is changing at a constant speed, constant rate? Anything? Raise your hands. Anyone? Please raise your hands. Yes, Arish. Yes, Arish.
Ma'am, mostly fuel prices.
The fuel price rate of change is not constant.
Oh,
They will increase somehow 10 rupees or 20 rupees or somehow 100, somehow 50. The rate of change is not constant. Anyone? Anyone? Nile, can you give me one example of rate of change? The constant rate of change. Arish, wait a minute. Nile, I'm talking to you.
Yes, ma'am.
Can you give me any example of rate of change, the constant rate of change?
No, ma'am.
Why?
Ma'am, I was absent yesterday's lecture.
This is the new concept. I'm just starting the new concept. I'm just asking the real life example. Can you tell me? Do you love cars?
Cars?
Yes.
Yes, ma'am.
You love to drive the car?
Yes.
Okay. If I will say that you are going at a constant speed of 60, you will be moving in a same pattern. If I'm talking about 60 kilometer per hour, is that the rate of change is constant?
Yes, ma'am.
Yes, this is the example. Yes, Arish. Wahi, Rohan, I'm coming to you. Just wait. Yes, Arish.
ma'am, the position of planets.
Position of the planets, the rate of change. That is actually that belongs to the bit of position of the planets. I'm talking about the rate of change,
Oh.
right? If there is no change, then it means that the function is constant. Then the function is stable, right? Yes, Rohan Fahim. Yes.
मैम ह्यूमन वॉकिंग भी एक एग्जांपल हो सकता है क्योंकि वो वॉक करके भाग भी सकता है.
Yes, definitely that will be the example of the real life example of a linear function. Yes, very good. Okay, anyone else? Anyone else who can give me the example? Anyone else? Azan Farooq, can you tell me? Afan, I'm coming to you, just wait.
Uh, Ma'am, any sort of automobile,
Yes.
like you can say a scooter or something.
Yes, the speed of the scooter, that's what I'm talking about. If the rate of change is constant, it means we are actually talking about a linear function. Afan, I'm coming to you. Afan, just a second. Yes, Afan.
Ma'am, inflation can be an example of the rate of change.
Uh, how inflation relates to the rate of change? The constant rate of change is there, but how the constant rate of change?
Ma'am, if the amount of the supplies decrease and of all the price increases, I think it would be a proper example of the rate of change.
I must add something. If the price of the basic needs increases, if the price of the basic needs increases, then we will not stop purchasing the basic needs. We have to buy it, right? Yes,
Yes,
Duret.
ma'am.
Yes, Duret.
Ma'am, what about rotation of Earth?
What about?
Rotation of Earth.
Yes, that is actually rotating in a constant rate. Very good, very nice. Yes, RS.
Ma'am, public transport.
Public transport. They are actually increasing the price at a constant rate. Are they increasing the price at a constant rate? I don't think so. I think they will increase the price at their own rate. Is it?
Okay.
But nice. Okay. Okay, beta, let's go further. Uh, what we were talking about the linear functions and their graphs. I said if the rate of change is constant, then we are actually talking about the linear function. But if the rate of change is not constant, the function will be somehow curved. Rate of change means if the rate of change is constant, there must be a straight line. That must be upward or a downward line, but it should always be a straight line, right? But if the rate of change is not constant, then the line will be somehow this way, somehow increasing, decreasing, increasing, decreasing, or it must be like this one. It can be like this one if the rate of change is not constant, but if the rate of change is simply constant, the line will move in a one direction. Its direction will not be changed. Okay. Now, if I'm talking about the direction, if I'm talking about the rate, then I must be talking about something that can be changed with the passage of time. If I will say, as you know, the petrol prices are actually hiked. Should we stop using the fuel? No. The fuel is our need. We have to, we will have to use the fuel in our daily life, right? Somehow the fuel usage is less, the consumption is less, but we are not doing, we will not stop using the fuel. Clear? So if one thing is changing, the other is also changing. That is known as a linear function. Let's take the example of this function where I'm saying the value of y is equals to 2x. It means that whatever the value of y is, the rate of constant change in x will be 2. Is this so? If I will say that the value of, if I will say that the value of y is 1, then what will be the value of x? Anyone who can tell me if the value of y is 1, if the value of y is 1, what will be the value of x? Anyone, raise your hands. If the value, I will put the values in the equation. 1 is equals to 2x. What will be the answer? Yes, Rohan Fahim. Very good. Yes.
If 1 is equal to 2x, then would the answer be 2? Or I think the answer would be 1x. 1x.
Think about it. See this. I just put the values in the equation, right? How you will solve the value of x? This 2 is multiplying with x?
So it becomes 2x.
No, this 2 is multiplying with x. Yes, 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 Afan.
Ma'am, if you're saying y equals 2x and y's value is 1, then of all the 2 will go down. So wouldn't it be 0.5 equals x or
Yes,
x equals
yes,
0.5?
yes. If y's value is 1, then the value of x will be 0.5. Is this so? Rohan, is this clear? Is this clear?
Yes, ma'am. Yes,
Okay.
ma'am.
Now, what if I'm talking about a constant rate? Where is that constant change? Where is that constant change? So let's take another example. If I'm talking about the value of x is equals to 2. If the value of x is equals to 2, then what will be the value of y? Then what will be the value of y? Yes, Afan.
Ma'am, in what circumstance? Like if x equals 2, so does that mean y is 2x?
Yes, y is 2x, which means that the value of y will be
Is 4.
is
Will be
4.
4.
Yes, it should be 4. It means if there is one change, 1 unit change, or 2 units change in the value of x, then the value of y will increase. How many units?
By that same amount.
2 more units increase, right? Is this clear to everyone? That's what I'm talking
Yes, ma'am.
about. Yes, Hassan.
Ma'am, the value of y is 4.
Value of y is 4. Very good. Okay, Shahram, can you tell me if I will say the value of x is 4, then what will be the value of y? Yes, tell me. If the value of
Ma'am,
x is 4, if the value of x is 4 in this function, then what will be the value of y?
8.
8. Yes. Yes, Aryan.
Ma'am, it is 8.
It is 8. Okay, Aryan, can you tell me if I will say the value of x is 5, what will be the value of y? Aryan? Yes, Aryan.
Ma'am, the value will be 10.
Value will be 10. So what I'm talking about the linear function. I'm coming to you, Azan. I'm coming to you. You have to tell me one more thing. That will be just a second. Mm-mm. Yes.
Yes, ma'am.
No, Fan. I am asking about Azan. I'm asking for the question from Azan. Azan, can you tell me if I will say the value of x is 6, what will be the value of y?
If the value of x is 6, the value of y will be 12.
12, yes. So it means I'm saying that the constant rate of change is 2. Is this clear? Is this clear to everyone what I'm talking about, the constant rate of change? Arish, can you tell me? Arish,
Yes, ma'am.
can you tell me that if the rate of change in, okay, let's talk about this function. If I will say x is equals to 7, what will be the value of y?
If y,
If x is
ma'am,
7,
y will equal to 14.
y is equals to 14, it means that this concept is crystal clear, that the rate of change is constant. What does it mean? That we have to change the rate of one variable, then the other variable will increase at a constant rate. Is this clear to everyone?
Yes.
Okay, nice. Let's go move further. Now, if I'm talking about plotting that points on a grid, plotting that points on a graph paper, for how I will plot the points. But if we can see the last figure, if I will say that here the value of x is 0, the value of x is 2, the value of y is 4. I have the coordinates 2 and 4, right? But if the value of x is 4, the value of y is 8, I have the other coordinate that is 4 and 8. It means that two of the coordinates are here, two of the points are here, that is A and that is B. I must say that I can easily draw the graph of this shape, right? Now, how I will plot the points? The plotting points are same as we have already done in the class, how to plot the points on a Cartesian plane. Clear? So this concept is not new for you. This is an old concept. I will move further, and now coming towards the practice now one, the practice now 1C. On your books, page number 15, practice now 1C, he have given us the function y is equals to 2x plus 1. I request you all to please open your books, page number 15, open your books, page number 15, practice now 1C. I'm reading the question. On a sheet of graph paper, using a scale of 1 centimeter to represent 1 unit on the x-axis and 1 centimeter to represent 1 unit on the y-axis. What does this mean? I'm coming to you and I will tell you that how to draw the graph. Clear? Draw the graph of the function y is equals to 2x plus 1 from the values of x from 0 to 4. The question is very simple. He said that you can take any value from 0 to 4 for the value of x. If I'm talking about the values of x from 0 to 4, I can take any value from 0 to 4 for the values of x. But how I will calculate the value of y? For example, if I will say that the value of x is 1, then what will be the value of y? I have to put the value of x in this function, then the value of x, y will automatically be in the figure. Clear? Is this clear? We already did this. We already did this in exercise 1A. Now, I have to calculate 2 multiply 1 is 2 plus 1. The answer will be 3. Is this clear? If I will say that the value of x is 1, if the value of x is 1, the value of y will be 3. Now I am asking from you, can you tell me that if the value of x is 2, if the value of x is 2, what will be the value of y? Anyone, raise your hands. If the value of x is 2, I'm talking about this function. If the value of x is 2, what will be the value of y? Anyone? Raise your hands. Yes. Same hands are raised again and again. Yes, Arish.
Y will be 5.
Y will be 5. Yes. How you calculate it? Arish?
Ma'am, cause simple
Yes.
2x, 2x, that means 2 multiplied by 2 plus 1.
2 multiply 2 plus 1. Yes. Afan, your answer was same. Okay.
Yeah,
So,
yes, ma'am. My answer is exactly same.
okay, good. Okay, beta. So, meanwhile, it's up to me that how much values I will be taking. If I'm taking 3 values, I will be taking x is equals to 2, x is equals to 1, or I can take x is equals to 0. So, if we have 3x values, then I will be having 3y values as well. So it means that we are actually putting the value in the equation in order to find the other coordinate, and that coordinate must be y or x. Clear? Is this clear to everyone? Now what I'm talking about, he said that take x as 1 centimeter. What he said, using a scale of 1 centimeter to represent 1 unit on the x-axis. It means the whole box contains 1 unit. I will write 1. The whole other box, I will write 2. The whole other box, I will write 3. The whole other box, I will write 4. 1 centimeter represents 1 unit on the x-axis, right? Now, he said 1 centimeter is equals to 1 unit. Again, you can take, you have the graph paper of the red sheet of graph paper. Tomorrow, but in fact, tomorrow I will show you the graph paper and we will plot the graph according to this scale. This is the scale where we have to put the values, right? Right now our class is just ending here. We have other concepts as well, but right now the main concept was in order to put the values in the given function. Clear? And this concept is, I guess, clear to everyone, that how we put the values in a given function and how the rate of change is changing with one variable. If we put the value of one variable in the equation, the other can also be changed. Clear? And if that change is constant, then we means that the rate of change is constant. It means that this is a linear function. Yes, yes, Rohan.
Ma'am, I have a question. If x is equal to 2 centimeter equal to 1 unit, then will 2 boxes equal to 1 unit of x?
Yes,
Okay,
right.
that's all I wanted.
On a sheet of graph paper, this scale is actually linked with the sheet of graph paper. This question is not linked with the question paper, with the question, or by putting the values. This concept is related to plotting the graph. Okay,
Okay.
we will be discuss this tomorrow, inshallah. Okay, right now I'm going to end the meeting. If you have any question related to this concept, you can ask me anytime. I have given you another home task. I'm giving you a home task that you have to find 10 real life examples of the rate of change, the constant rate of change in our daily life, right? Clear? Okay, I have to end the meeting. If you have any question, you can ask me anytime. Clear? Meanwhile, I'm going to end. Okay, take care. Allah Hafiz.